All right, this is Honors Algebra 2 Pre-Calc. We're doing 6.7 in Algebra 2. This is our third video, solving exponential equations with multiple exponential terms. It is the last video in the section and also the last video in the chapter. So recall that we weren't able to use SADMEP to solve an equation that had multiple powers of x, right? That's when we had to use factoring. So here's an example, x squared minus 2x minus 3 equals 0. You have to use factoring to solve, right? Here's another example, right? X cubed minus x squared equals 0. Multiple powers of x, we have to use factoring to solve. The same is true when you have an equation with multiple exponential expressions like this. E to the 2x minus 5 e to the x plus 6 equals 0, or e to the 2x minus 4 e to the x equals 0. So we're going to walk through some examples of how to do this. It is kind of important to note that e to the 2x is the same as e to the x quantity squared, right? Based on the way that the properties work with exponents, you could rewrite an e to the 2x as an e to the x quantity squared, and that's going to end up being important. Okay, so let's start with this one. So we're going to give exact answers only. So in this situation, right, remember that this is the same as an e to the x quantity squared minus a 5 e to the x. There's a GCF, okay? So there is a GCF of e to the x. And if I factor out that GCF, right, if I factor out the GCF of an e to the x, what's left is the other e to the x, because remember this was an e to the x quantity squared, minus a 5. So either e to the x equals 0, which we're going to talk about in a sec, or e to the x minus 5 equals 0. Well, e to the x equals 0 is actually a lie, okay? Because if you, so this piece right here has no solution, and I'm going to show you why. Recall what an exponential graph looks like. An exponential graph looks like this. This is e to the x, right? Remember that it has an asymptote, right? This never reaches 0, right? More specifically, e to the x is positive, right? E to a power is positive. So this is a lie and there's no solution. There is, however, going to be a solution for the other one. So we're going to solve that one. So if I solve this one using subtraction and addition first, I get e to the x equals 5, right? I did subtraction and addition. There is no division and multiplication. And to get rid of an e to the x, I need to take the natural log of both sides, right? So what's going to happen is I'm going to get that my answer is x is the natural log of 5. And that is the only answer. You weren't asked to find an approximate answer, so you should just leave your answer as the natural log of 5. All right, now there's another way to get there. Let's say you didn't spot this no solution thing that I said here. Let's say you didn't see it. The other way to get there is you could have said, hey, I don't see it. So if you don't see that, then you would have said, oh, natural log of e to the x equals natural log of 0. Wait, that means x is natural log of 0. But then your brain should be like, uh-oh, only positives inside logs. And that should spit you back to, oh, hey, this doesn't give an answer, okay? All right, so let's go ahead and try one. You give this a shot, right? Again, same thing, there's a GCF here, right? Remember, this is an e to the x quantity squared minus a 4 e to the x equals 0. So when we take out the GCF, we're going to yank out an e to the x, and what's going to be left is e to the x minus 4 equals 0. So either e to the x equals 0, and again, I would suggest you just get used to the fact that that's not going to happen, or e to the x minus 4 is 0, so e to the x is 4. When I take the natural log of both sides, I get that x is the natural log of 4, and that's our answer. All right, let's do one that's slightly harder. So in E7, this is tricky because now I have this third term and there is no GCF, okay? So this is what I like to call a secret quadratic trinomial. And sometimes I sound like Elmer Fudd when I say it, so I try to enunciate clearly. So sometimes I sound like I'm saying secret quadratic trinomial. All right, so secret quadratic trinomial. All right, so if I remember that this is actually an e to the x quantity squared minus an e to the x minus 12, you've seen these before. We're going to say, let's call this linear term u. Well, wouldn't that make this u squared minus u minus 12, which we know how to factor, right? So this factors into a u minus 4 times a u plus 3, right? Because I need the 12 to have two things that have opposite signs, right? So either u minus 4 is 0, right? Which would be u equals 4. Right? Or u plus 3 is 0, which would be u equals negative 3. And actually, at this moment, you could go back up and use the factored form here if you want. at this moment. And notice that 4 and negative 3 are not my answers. So this would be e to the x minus 4 and e to the x plus 3, right? So either e to the x minus 4 is 0, which gives me e to the x equals 4. And when we take the natural log of both sides, I would get the natural log of 4 as my x, right? Or e to the x plus 3 is 0, which is a lie. And there's a bunch of different ways to see that this is a lie. But the biggest one is we've already established that e to the x is always positive. So my only answer is the natural log of 4. Now, if you had done it where you solved all the way down here for the u, you would have had to replace this u with an e to the x and finish solving. And then you'd get in the same spot. You'd get a natural log of 4 for this x, or you'd get no solution because this one's a lie, right? That's not a solution. You can't take the natural log of negative 3. Okay, so you're going to go ahead and try a P7, and then that'll be it for our chapter 6. So again, and how much you need to write here is really going to depend on you personally. If you can look at this and see that this is one of those secret quadratic trinomials, if you can say, wait a second, I don't need this u, I understand what's happening, I don't need it, that's great, right? If you do need it, that's also great, I don't care. I just care that you're able to get the math solution correct, right? So my two factors are going to be e to the x minus 2, e to the x minus 3. So either e to the x minus 2 is 0, which is e to the x equals 2. X is a natural log of 2 when I take the natural log of both sides. Or e to the x minus 3 is 0. E to the x is 3. X is the natural log of 3. So here I do have two answers, right? And so those are both my answers. All right, that's it for our video and for chapter 6.